Hey everyone, welcome back to my channel. In this video, I'll be going over how to call functions to use code that other people have written and how to use nested expressions. Be sure to click the card icon in the top of the screen to watch my previous video where I covered the basics of Python variables and comments if you haven't already. Also, be sure to give this video a like. With that said, let's get straight into the video. So the most common way to combine or manipulate values in Python is by calling functions. Python comes with many built-in functions that perform common operations. For example, the absolute function takes in a single number as its argument and returns the absolute value of that number, which we see here, these two cells. Another built-in function is the sum function, which takes in a list or some other iterable variable and returns a sum, which is shown here. In addition to using built-in functions, we can also write our own functions. To write our own function, we use the following format: def, function name, parameters in parentheses, colon, function comments that are tabbed in once, and our code that's also tabbed in once. For example, I created this add number functions here, which takes in two numbers and returns the sum. To call this function, we can type the function name and pass in two numbers. So let's work on a real-life application where we compute walking distances. In this example, David is on the corner of 7th Avenue and 42nd Street in Midtown Manhattan, and he wants to know how far he'd have to walk to get to Gramercy School on the corner of 10th Avenue and 34th Street. He can't cut across blocks diagonally since there are buildings in the way. He has to walk along the sidewalks. Using the map, he sees he'd have to walk 3 avenues or long blocks and 8 streets or short blocks. In terms of the given numbers, he computed 3 as the absolute value of 7 and 10 for avenues, and 8 similarly for streets. David also knows that blocks in Manhattan are all about 80 meters by 274 meters, since avenues are farther apart than streets. So in total, he'd have to walk 80 times the absolute value of 42 minus 34 plus 274 times the absolute value of 7 minus 10 meters to get to the park. So let's finish the line num avenues away so that the cell calculates the distance David must walk and give it the name Manhattan distance. So looking at how num streets away was calculated, we can compute num avenues away by taking the absolute value of 7 minus 10. And if we run this cell, we get 1,462 meters as a Manhattan distance. So some functions take multiple arguments separated by commas. For example, the built-in max function returns the maximum argument passed to it, which we see here. Now, let's look at nested expressions. Functions called arithmetic expressions can themselves contain expressions. We saw an example of that in the last checkpoint with absolute value of 42 minus 34, which has two number expressions in a subtraction expression in a function call expression. Nested expressions can turn into a complicated looking code. However, the way in which complicated expressions break down is very regular. Suppose we are interested in heights that are very unusual. We'll say that a height is unusual to the extent that it's far away on the number line from the average human height. An estimate of the average human height is about 1.688 meters. So, for example, let's say we have a friend, Aditya. If Aditya is 1.21 meters tall, then his height is the absolute value of 1.21 minus 1.688, or 0.478 meters away from the average, which is shown here. And here's how we write that in one line of Python code. For reference, 0.478 meters is about 1.5 feet. So what's going on in that code cell? Well, the absolute function takes just one argument. So the expression inside the parentheses is all part of that single argument. Specifically, the argument is the value of the expression 1.21 minus 1.688. The value of that expression is negative 0.478. That value is the argument to the absolute function. The absolute value of that is 0.478. So 0.478 is the value of the full expression from step 1. In fact, that's basically what Python does to compute the value of the expression. So let's say we have another friend, Botan, and his height is 1.85 meters. In the next cell, let's use the absolute function to compute the absolute difference, or rather the absolute value of the difference between Botan's height and the average human height. So we write the absolute function of 1.85 minus 1.688. And we get that about 0.162 meters as its distance from the average in meters. Now, say that we want to compute the most unusual height among Aditya's and Botan's heights. We'll use the function max, which again takes two numbers as arguments and returns the larger of the two arguments. Combining that with the absolute function, we can compute the biggest distance from the average among the two heights. For simplicity, I went ahead and filled in the values for their heights in the calculations. So we get that the biggest distance from the average height among these two people is 0.478 meters. The line where biggest distance m is computed looks complicated, but we can break it down into separate components just like we did before. The basic recipe is repeated simplification of small parts of the expression. We start with the simplest components whose values we know, like plain names or numbers such as Aditya height m or 5. Next, we find a simple enough group of expressions. So we look for a group of simple expressions that are directly connected to each other in the code. For example, by arithmetic expression or as arguments to a function call. Then we evaluate that group. So we evaluate the arithmetic expressions or function calls they're a part of and replace the whole group with whatever we compute. For example, we had Aditya height m minus average adult human height m, which becomes negative 0.478. After that, we continued this process using the values of the combined expression as our new basic components. So for example, the absolute value of negative 0.478 becomes 0.478, and so on. We keep doing that until we've evaluated the whole expression. So we can see a diagram of that process here. So in this diagram, the orange boxes highlight the max and absolute functions, and the blue boxes highlight the individual values. So let's take what we learned today and apply it to this next example. So given the heights of the Splash triplets from the Golden State Warriors, let's write an expression that computes the smallest difference between any of the three heights. Since we want the smallest difference, we can use the built-in min function. Now we can write the differences between the three heights using the absolute function and subtraction. So the absolute value of Clay minus Steph, the absolute value of Steph minus Kevin, and the absolute value of Clay minus Kevin. So we get that the smallest height difference is about 0.05 meters or about 0.16 feet. So I hope you learned how to make function calls and nested expressions in Python. If you found this video helpful, be sure to hit the like button, subscribe to my channel, and hit the bell to get notified when my videos get uploaded. Also, comment down below what you learned from this video and what other topics you want to see. And share this with anyone interested in learning about data science. With that said, thanks for watching, and I'll see you in the next video.